Tonight's lesson is on Chapter 7-8. This is the last section in Chapter 7. This one's on geometric sequences. We've talked a little bit about arithmetic sequences in the past, and that's when you're adding and subtracting the same number. Geometric sequences are really the same thing, except each time instead of adding and subtracting, you're multiplying or dividing. So what is a geometric sequence? I just kind of gave you a little heads up on that, but this first one, to go from 3 to 6, you multiplied by 2. To go from 6 to 12, you multiplied by 2. 12 to 24, you multiplied by 2. So each time you're multiplying by 2. That one's going to be geometric. To go from 4 to negative 4, you multiply by negative 1. From negative 4 to 4, you multiply by negative 1. So each time you're multiplying by negative 1. So that's going to be a geometric sequence. But then this last one, 4 to 8, you're going to multiply by 2. From 8 to 12, you're not multiplying by 2. So because I'm not multiplying by the same thing each time, this one is not geometric. Now this one is arithmetic because you're adding 4 each time. So that one's arithmetic, just not geometric. So let's identify a geometric sequence. It's pretty easy because all you have to do is figure out what you're multiplying by. So A right here is, if you'll notice, it's just adding a 0 every time. So that means you're multiplying by 10 times 10 times 10 times 10. So that means that your common ratio, which is part of a geometric sequence, so your common ratio for this is 10. Yes, it's a geometric sequence. Common ratio is 10. Alright, B, 2, 4, 6, 8, 10. At first you think, okay, you're multiplying by 2, but you can't multiply by 2 here. So you're not multiplying by 2, you're just adding 2 each time. And that is not geometric. I'm just going to put not geo. It is arithmetic, but it's not geometric. Anytime it's changing signs on you, like this third one right here, it's trying to trick you because you think, oh, you're not multiplying by anything, it's staying the same each time. But you are, because it's going from positive to negative to positive to negative to positive to negative. So what you're doing is you're multiplying by negative 1 each time. So if it asks you, is it geometric, you're going to say yes. And the common ratio is negative 1. And by common ratio, I mean, what are you multiplying by? Okay, pause the video. Answer number 1, A and B. I need to know, is it a geometric sequence? So you're going to say yes or no. And then if it's not geometric, you're going to tell me, is it arithmetic? Are you adding the same thing or multiplying by the same thing? Actually, what you can do for these two is just say geometric or arithmetic. Alright, example 2, finding recursive and explicit formulas. We want the recursive formula for this. You're supposed to remember this, but I never assume you remember anything. So there's two different kinds of formulas. Recursive is you're doing the formula over and over and over again. You're going to use the formula to find the next term, and then the next term, and the next term. Recursive, it's recurring over and over again. And explicit is whenever I say, I need to know the 107th term, then you're going to find the 107th term for that one. Okay? And you go straight to it. You don't have to find every term between there. And I've gone ahead and just written the formulas for you. So this one's recursive, and this one's explicit. So those are the formulas, and you're going to use those to plug in your information and figure out what the formula for this specific sequence is. So by A sub n, what I mean is the number of term you're talking about. So if I said A sub 2, that's going to be the second term, or 21. So this will be A sub 1, A sub 2, A sub 3, A sub 4, and when I say A sub n, I mean whichever term you're telling me about. Then when I say a sub n minus 1, I'm talking about the term before that. Okay? N minus 1. If I'm saying the third term, N minus 1 is going to be the second term. So that's going to be the term before the third term. And when I say A sub 1 here in the explicit formula, I'm talking about the first one. When I say N in the explicit formula, I'm talking about whichever number term you're asking me for. If the problem asks for the 107th term, then N is 107. Okay? So we're going to find both of these. So for A sub N, at the moment, they're not asking me for any term. They just want the formula. So I'm going to leave A sub N and A sub N minus 1 just like it is. And all I have to do for the recursive formula is say what's the common ratio. So we need to take a look at our sequence. It goes 7, 21, 63, 189. And the common ratio is going to be 3. So R equals 3. So for the recursive formula, A sub N equals A sub N minus 1 times 3. And you're going to say, always say the first term whenever you're asked for the recursive formula, because you have to have a starting point. So that's one answer. And then for my explicit, and I'm going to call this recursive, and then for my explicit, we are going to plug in our first term, which is 7. So it'll be, oops, how about I use my pen? A sub N equals, the first term is 7. The common ratio goes here, and that's 3. And then they haven't asked me for a term, so N gets to stay N. So we're going to say N minus 1. Okay? And that's your explicit formula. Alright, for got it number 2, I want you to write me the recursive formula and explicit formula for this. So I'm going to write you the little formulas for it. The recursive is A sub N equals A sub N minus 1 times R. And the explicit is A sub N equals A sub 1 times R to the N minus 1 power. For your sequence right here, your R is going to be what you're multiplying by each time. And your A sub 1 is going to be the first term right there. Okay? That's the only information you have to plug in. Pause it, do the question, and get back with me in the next slide. Okay, there is a use for these sequences, so every time remember that you ask what the use is for the sequence, you're going to get a word problem most of the time. So here's your question. 2 managers at a clothing store created sequences to show the original price and the markdown prices of an item. Write a recursive formula and an explicit formula for each sequence. What will the price of the item be after the 6th markdown? Alright, so I realize I left off part of the problem when I put this picture on here. But anyway, that's going to be our markdown. So if you look at the chart, this is the markdowns. The first markdown, it was $18. Second markdown, it was $9. Third markdown, it's $4.50. What will the price of the item be after the 6th markdown? So we've got 4, 5, and 6 more to go. And I need a recursive formula and an explicit formula. So the recursive formula is going to be A sub N equals A sub N minus 1 times the common ratio. So from here to here, I halved it. From here to here, I halved it. So it's going to be half, or 0.5. The explicit formula is going to be A sub N equals A sub 1, what's the first term, 18, times R, the common ratio, to the N minus 1 power. So those are my two formulas. And then I need to know what the price of the item will be after the 6th markdown. Now you can do it either way. You can keep going with the recursive formula, which is really what you're doing when I say extend the sequence, and you just keep going and keep finding that you're doing the recursive formula whether you know it or not. Or you can use the explicit formula, and that's the one I'm going to use. So I'm going to go in under this explicit formula right here, and I'm going to plug in 6 because they're asking me for the 6th markdown. I'm going to plug in 6 right there. So that's going to be a sub 6, not n, 6. Let's see, eraser. Where's my eraser? There it is. A sub 6 equals 18 times 0.5 to the 6th minus 1. So in your calculator, you are going to put in 0.5. Well, 6 minus 1, everybody knows is 5. So you're going to do 0.5 to the 5th power times 10. Times 18. And I got 0.56. And so that item's going to now be 56 cents since they've marked it down so many times. You can check your answer when you do it this way by just keep going. And since I'm halving it each time, half it again, that'll be 4. Half it again, that'll be 5. Half it again, that'll be 6. And it should give you 56 cents. Okay, forgot it. Number 3, I want you to write a recursive and an explicit formula for this sequence. And then find the 8th term. So actually what I'm going to have you do is just write the explicit formula of the sequence. So I'm going to write the formula for the explicit formula. It's a sub n equals a sub n minus, no, a sub 1. Just kidding. Sorry, that's the recursive. It's a sub 1 times r to the n minus 1 power. Okay? And I want you to tell me the 8th term. Pause it, find the 8th term, and then catch up with me on the next slide. Okay, example 4, writing geometric sequences as functions. A geometric sequence has an initial value of 6 and a common ratio of 2. Write a function to represent the sequence. Graph the function. It's the same thing as writing the formula, except you're using different variables. So if I needed a function, I'm going to have x's and y's. So I'm going to use this table, and I'm going to make myself a table representation of the function. So it has an initial value of 6. So x is going to be my a sub n. My n. Just kidding. X is going to be my n, and y is going to be my a sub n. So this means that this is going to be my number of term, and this one's going to be my term itself. So my first term, if it has the initial term of 6, is 6. If I'm multiplying by 2 every time, my second term is going to be 12, and my third term is going to be 24. So if I had to write my geometric sequence, the explicit formula for this geometric sequence, that would be, remember, a sub n equals a sub 1 times r to the n minus 1. So that's going to be a sub n equals, the first term is 6, times, the common ratio is 2, and that's going to be to the n minus 1. Except since I'm writing a function, I need to replace the a sub n and the n with the variables we use, so x and y. So where this is going to be y equals 6 times 2 to the x minus 1 power. And that's my function. And it also says graph it, so let me grab some graph paper really quickly. And I'll graph this 1, 6, it's going to be close to there, 2, 12, close to there, 3, 24 would be way up here. And if I went back to 0, that would be 3. So it's looking kind of like a curve. Kind of like exponential growth. Huh? You remember that? Yeah. So geometric sequences graph curves just like exponential growth and decay. That's what you need to see from that. Alright, same thing. We have a geometric sequence, so let's make a table with initial value of 2, first 2, and a common ratio of 3. So 6 times 3 is 18. And then you keep going. We're going to call this x and y. But remember, it used to be called n and a sub n. I want you to write a function to represent the sequence and then graph the function. Okay? Pause it. If you need help, and I can understand where you need help on this, definitely go back and look at the other one. And if it's really bad, text me on Remind 101. Okay? But pause it, get it done, catch up with me on the next slide. Okay, if you have any questions, again, email me, Remind101 text, get up with me on Twitter or Instagram, or message me on Facebook, and please do not forget to participate in the online discussion for your bonus credit. You can do it on either Twitter, Instagram, or Facebook, but not all three, just on one. Okay? Good night.